So for this lesson, homework number 4, we're talking isosceles triangles and equilateral triangles. Now we've already discussed that isosceles means that two sides are equal. But we want to talk about some more properties that we got going on in these triangles. Isosceles you sometimes talk about as the Christmas tree triangle because it's often, not always, but often looks like a Christmas tree. And these two legs right here are equal. Now let's talk about a couple parts. These two purple pieces we're calling legs. And in this particular drawing, the legs are equal to one another. And this one right here, the green one, is the base. Now base just meaning the bottom. If we happen to move this around, or we had a different triangle, the base is just the bottom. And then lastly, this little piece up here, if this was a Christmas tree, where you would put the star right there is what we call the vertex. Okay, and so if a triangle is isosceles, then its base angles, which we call here, because they're the angles made by the base, are equal. And that makes sense going back to a couple lessons ago where we talked about the side across from it being related to that angle. And so if these two sides are the same, then the angles across from them are also the same. So looking at an example like this, they want us to find x. Well, normally you'd say we don't have enough information because we know that all three of these add up to 180, but they only give me one. And so, Ramsey, stop. Come here. So, we know if this is 80, then this has to be 80 because it's isosceles. And then from there, you just do what you did earlier. These added together is 160, and 180 minus 160 means x has got to be 20. X has to be 20 degrees. Alright, moving on up here to equilateral. Equilateral means equal, lateral meaning sides. All the sides are equal. And we talked about, I think before, that if all the sides are equal, the angles are also equal. So not only is this equilateral, it's also equal angular. So this side, and that side, all the same. So if a triangle is equilateral, and all of the angles are equal, and they all have to add up to 180, well then they have to be 180 divided by 3, which is 60. Since they're all the same, this has got to be 60, this has got to be 60, and that's got to be 60. Right, and that really is the meat of this lesson. Really, it's that simple. Is that if there's an isosceles triangle, the base angles are the same, and if it's equilateral, all the sides are the same, and all the angles are 60. And those two very, very simple ideas are going to help you a whole lot as some of these problems start to get more and more complicated. Okay, so let's look down here at number 2. Okay, again, it looks like you're given not a whole lot of information, but the first thing you need to notice are these and say, oh yeah, it's equilateral. And if it's equilateral, I know this has got to equal 60. So 2x has got to equal 60. Divide both sides. X has to be 30. Oh yeah, this has got to be 62. Divide both sides by 3. And y has to be 20. And it's really that easy. Okay, looking at example 3. At first glance, this thing is intimidating. I mean, what is going on? All kinds of things. But I want you to learn to just take it one step at a time and just break it down and start with what you know. Okay? And so if you notice right away these tick marks, and my eyes just kind of go towards this triangle because that's where the number is. So they've given us a number, and then you kind of just notice these are the same. Two of the sides are the same. It means it's isosceles. And if it's isosceles, these angles are the same. Alright, so I got one piece. And with a lot of these problems, it's almost like dominoes. And that if you knock one of them, they all just start to fall. Just like that. And it's just almost like once we get this, oh yeah, these have to add up to 180. So 58 plus 58 is 116. I'm going to subtract that from 180 and get 64. So I already got x. X has got to be 64. Box that in. I'm halfway there. Okay, now we may get stuck again and say, all right, what now? But then we say, oh yeah, this box means that's 90. And if I turn it this way, maybe to help myself, I see these are the same. Now notice as this has 2 tick marks, so this isn't equilateral. You know, some people may say 60, 60, 60. I mean, the 90 is a giveaway. It can't be equilateral. But these two are the same. This is different. If these two are the same, they're isosceles. Okay, and so we're given that this is 90. So 180 minus 90 is 90. Meaning that these two have to add up to 90. Well, they're the same. So if we split 90 in half, we find out that this is 45 and this is 45. And this 45, 45, 90 triangle is going to show up all over the place. That's a famous triangle. Okay, and then lastly, this is an idea that we've been using over and over again since the beginning of the year, and that's noticing here we have a straight line. So this angle, and that angle all together make 180 degrees. And so add these two together, you get 109, and I'm going to subtract that from 180 and figure out that y has to be 71. Okay, moving on now to example 4. Let's just take it one step at a time. And we see this is 40. Does that mean this is 40? No, not necessarily. I mean, this is isosceles, but this isn't the whole angle. It's like this weird part of the angle. I don't have any information here. And you may go through that. You should go through that, where you start in a place and you start to say, no, no, no. Oh, this is equilateral. The big one is all of these sides are equal. So I know equilateral triangles are, this is 60, this is 60, and so this has to be 20, obviously. And then this is 60. That whole big thing has got to be 60. Now, it's not necessarily the same as over here, because, you know, this could be cockeyed in there. We don't know exactly that it's the same. But if we come down here, we see this is isosceles. So we know for sure. This is a fact. We're not just guessing. We're not assuming. We're not saying it looks like they're the same. We know they're the same because isosceles triangles, the base angles are the same. And so if this is 20, now we know for a fact that's got to be 40. 20, 20, 40, subtract from 180, and this is 140. Okay, that's simple. I love these kind of problems. I just think they're fun. Okay, flipping over, here we got one that's going crazy. It's hard for me to even fit it on the screen. No markings at all, but it tells us down here, BFD is equilateral. Boom. Mark it up. And you may want to already just say, oh, I know, equilateral, 60, 60, 60. Okay, and then ACE, which is this big triangle, is isosceles. Now, it's kind of hard for us to mark that just because these are kind of in the way. But, you know, you may get a highlighter or something and do this, whatever you want to do. Say, okay, I know this is isosceles. And if it's isosceles, then these angles got to be the same. Well, they give us 40 here. 180 minus 40 is 140. And so these have to be the same, so I'm going to divide it in half and find out these both have to be 70. Okay, it wants us to find all of the missing angles. And so we just kind of have to, we've used this piece of information and that piece. So now we just kind of have to scan our drawing and say, okay, what else can we figure out? That's a triangle. These three have to add up to 180. So 50 plus 70 is 120. Subtract 180 and you get 60. Alright, that's got to be 60. What else? I only got one angle in this one. Only have one here. Oh yeah, a straight line. Right here. This one is 50 plus 60 plus that has got to equal 180. You know, you may have put 50 here thinking, well, they look like they're the same. They're not. It's actually not 50. Add 1650 is 110. Subtract it from 180, and you find out this thing is 70. And then you come over here and say, oh yeah, there's a straight line going on this side too. And so I know that these three got to add up to 180. So 60, 60, and 60 is going to give me 180. And then, just like I said before, this is dominoes. This is all kind of falling in our laps now. This is 100. So that's got to be 80, because they have to equal 180. And then these have to equal 180, which makes that 40. And we'll check this. That equals 182. Bang. That easy, everything's falling in our lap. Okay? Last example, example 6. And this is not something that you're going to see a whole lot of, but I just want to connect it back to some previous material. And what they're telling us is that TUS, which is here, I'm just going to go ahead and mark it, is equal to QSR. TUS, QSR. And they want us to prove that. Now, at first glance, it's like, whoa, you know, how am I going to do this? But let's just take it one step at a time. I'm going to label this 1, call that 2. I'm just going to call that 3 and 4 too. I don't even know if I'm going to need them, but just to label them, that'll make it easy. So, first thing first, you should see that angle 1 is congruent to angle 3. And that's something you should be really good at spotting out by now. These are vertical angles. I mean, how many problems have vertical angles been in? Like 12 million. So if these are the same, well, if these are the same and this is the same as that, I mean, they told us that angle 1 was equal to angle 2. They told us that one. Okay, and we kind of, you know, if 1's equal to 3 and 1's equal to 2, well, then 2 and 3 are obviously equal to each other. I mean, that's really, we're just substituting. It's also called the transitive property, but you can just write substitution. And then we'll notice if the base angles are the same, and I've obviously drawn this very badly, but if the base angles are the same, then what kind of triangle does this have to be? It's got to be isosceles, right? I mean, it's the opposite of our theory from earlier. These are the same, which means, okay, this has got to be an isosceles triangle. We just got what we were trying to prove. We just said TS is equal to TU. How do we know that? Well, it's because of the isosceles triangle. And there's our proof. We're going to get a couple more different proofs like this. This is going to be harder than one you're going to see, but I just wanted to show you that one. But that's really it. Make sure that you write a question. Write one down. I know you probably have one from this lesson. Anything I can help you with, come in tomorrow. Ready to work hard.